December 7th, 1942. Tunis, North Africa. Major Carlo Bellini of the Regio Esercito's Automotive Technical Division stands in a captured British motor pool, his boots grinding against sand mixed with engine oil. Around him, mechanics catalogue seized equipment, Bren carriers, lorries, motorcycles, standard fare. But Bellini's attention fixes on something else entirely. Preparing and narrating this type of story took us long efforts and hard work. So if you are enjoying the story, please consider subscribing to our channel. There, parked between two damaged trucks, sits a small American vehicle, squat, angular, stripped of pretense. 4 wheels, a flat hood, no doors, a canvas top folded back, stenciled on the hood in white paint, USA, followed by a serial number. The designation tag reads Willys MB, 1941. Bellini approaches slowly. He's 41 years old, an engineer from Fiat's military vehicle division in Turin, commissioned into the army, specifically for technical intelligence work. His orders were explicit: examine Allied automotive equipment, assess capabilities, report vulnerabilities. What he doesn't know yet, what nobody in Rome understands, is that this crude little machine represents an industrial and philosophical revolution Italy cannot replicate. The Jeep. Weight: 1,120 kilograms empty. Payload capacity: 363 kilograms officially. But the technical manual Bellini finds in the glove box lists something else. A penciled note in English. Hauled 800 pounds ammo across Halfaya. No problems. Don't believe the manuals. 800 pounds. 363 kilograms. On a vehicle weighing barely over a ton. Across North African terrain that destroys Italian trucks rated for twice the payload. Bellini studies the Jeep and cannot make sense of it. The construction appears almost primitive. Flat stamped steel body panels, exposed engine, minimal creature comforts, no sophistication. Yet intelligence reports claim these vehicles operate everywhere. Desert, mountain, mud, snow. Places Italian equipment fails regularly. He pulls out his field notebook and begins recording measurements. Over the next 6 weeks, Bellini will disassemble this Jeep completely. He will test every component, analyze every design choice, calculate every engineering compromise, and he will discover something that changes his understanding of military logistics forever. Sometimes the winner isn't the one with the best machine. It's the one with the good enough machine that can be everywhere, always, without fail. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. When we imagine World War II vehicles, we see tanks, half-tracks, armoured cars, machines of war bristling with weapons and armour. Yet the statistics tell another story. The greatest impact on Allied victory came from a vehicle carrying no armour whatsoever, mounting no weapons, designed not to fight but simply to move. The Willys MB Jeep and its Ford GPW twin. Production total: 640,000 units between 1941 and 1945. More than all German tanks, all Soviet tanks, all American tanks combined. Italy, by contrast, produced approximately 11,000 military vehicles of all types during the same period. The quantitative gap staggers. But Major Bellini, standing in that Tunis motor pool in December of 1942, doesn't know these numbers yet. He knows only that intelligence reports from every front mention this vehicle. British forces use captured Italian Jeeps. German forces use captured American Jeeps. Everyone wants them. Nobody understands why they work so well. The story begins earlier. 1940, United States Army. Europe burns. Poland fallen. France collapsing. American military observers watch German blitzkrieg tactics and understand everything. Modern war requires speed, mobility, reconnaissance in depth, but the US Army's standard reconnaissance vehicle, the motorcycle with sidecar, proves inadequate. Motorcycles bog in mud, tip on rough terrain, carry minimal cargo, expose riders to fire. The cavalry wants light tanks, Armour Branch wants more half-tracks, Infantry wants trucks. What arrives instead is something nobody requested, a specification. June 19th, 1940. The Quartermaster Corps issues requirements for a light reconnaissance vehicle. Weight, maximum 590 kilograms. Payload, 272 kilograms. Wheelbase, 2 meters. Height, maximum 1 meter 16 centimeters. Four-wheel drive mandatory. 3-speed transmission. Maximum speed, 80 kilometers per hour. And the crucial requirement, prototype delivery in 49 days. 49 days to design, engineer, and build a completely new military vehicle. American Bantam Car Company, a tiny manufacturer in Butler, Pennsylvania, desperate for contracts, submits the winning bid. They partner with designer Karl Probst. Probst works 72 hours straight, produces blueprints in 2 days. The prototype, called the Bantam Reconnaissance Car, appears on September 21, 1940. Weight, 610 kilograms, 20 over specification. The Army tests it anyway. The little vehicle climbs 40-degree slopes, forges streams, averages 70 kilometers per hour cross-country, carries 4 men plus equipment without complaint. Quartermaster officers stare in disbelief. One writes in his evaluation report, "This vehicle performs tasks we didn't know needed performing. It redefines reconnaissance. Recommend immediate production." But the Army worries. Bantam lacks manufacturing capacity. They send specifications to Willys Overland and Ford, larger companies with assembly line experience. Willys produces the MA model. Ford creates the GP General Purpose, later nicknamed Jeep. All 3 designs converge. The Army standardizes on Willys's chassis and engine, Ford's body stampings. By July 1941, production begins. Target, 16,000 units by year's end. The Willys MB, finalized design. Length, 3 meters 30 centimeters. Width, 1 meter 58 centimeters. Height with windshield down, 1 meter 33 centimeters. Wheelbase, 2 meters 3 centimeters. Engine, Willys Go Devil, 4-cylinder inline, displacement 2.2 liters, output 60 horsepower at 4,000 revolutions per minute. Transmission, Warner T84, 3-speed with high-low transfer case. 4-wheel drive with lockable differentials. Suspension, semi-elliptical leaf springs front and rear. Ground clearance, 22 centimeters. Fuel capacity, 57 liters. Range, approximately 300 kilometers. Weight empty, 1,120 kilograms. Official payload, capacity, 363 kilograms. Top speed, 105 kilometers per hour on road. Cross-country speed, typically 40 to 50 kilometers per hour depending on terrain. Unit cost, $740, roughly $2,200 in modern value. Simple, crude even. But it works. American forces deploy Jeeps to Britain in 1941. British troops see them, test them, immediately request thousands. Soviet Union receives 14,000 Jeeps through Lend-Lease. Red Army commanders call them Willys, pronounce it Willys. Prefer them to Soviet-built vehicles. By December 1941, when America enters the war, Jeeps serve on every continent except Antarctica. Italy, meanwhile, produces the Fiat AS-42 Sahariana, a purpose-built desert reconnaissance vehicle. Sophisticated 4-wheel drive, 3 differential locks, spare tires mounted everywhere. Weight, 4,700 kilograms. Crew, 4. Armament, various. Configurations. Range, approximately 400 kilometers. Production total, 200 units. It's a good vehicle, well engineered for specific conditions. But there are only 200. The Fiat Topolino 508 cm Coloniale Militare serves as Italy's light vehicle. Displacement, 1.1 liters. Output, 32 Horsepower, two-wheel drive. Payload, approximately 200 kilograms. Weight, 590 kilograms empty. It works adequately on roads, struggles everywhere else. By 1942, Italian forces in North Africa have captured dozens of British and American jeeps. Commanders hoard them, use them for headquarters vehicles. Reconnaissance, ambulance duty, anything requiring reliability. Which brings us back to Major Bellini standing beside that captured jeep in Tunis, December 1942. The Axis holds North Africa, barely. British 8th Army pushes from the east. American forces land in Morocco and Algeria to the west. Italy's colonial empire crumbles. Supply lines stretch impossibly thin. Equipment failures mount daily. And here sits this American vehicle, mud-caked, battle-scarred, abandoned only because it ran out of fuel. Bellini climbs into the driver's seat. The interior is Spartan. Stamped metal dash, simple gauges, fuel, oil pressure, ammeter, speedometer, temperature, nothing decorative, nothing unnecessary. The steering wheel is thin, hard plastic. Pedals are plain steel. The shifter, a simple lever extending from the floor. He pulls out the technical manual again, studies the four-wheel drive system diagram, sees something remarkable. The transfer case offers 6 forward gears effectively, 3-speed transmission multiplied by high-low range. Low range provides climbing power. High range provides road speed. Drivers can shift between 2-wheel and 4-wheel drive without stopping. Differential locks engage via simple mechanical linkage. No complex hydraulics. No electrical components prone to failure. Pure mechanical advantage achieved through clever gear ratios. He starts the engine. The Willys Go Devil fires immediately despite sitting abandoned for 3 days. Bellini listens to the rough 4-cylinder thrum. Not smooth, not quiet, but dependable. The engine design dates to 1941, adapted from Willys's civilian power unit. Nothing revolutionary, just good engineering executed reliably. He engages the clutch, shifts into first gear, low range, 4-wheel drive. Releases the clutch. The Jeep lurches forward. He steers toward a sand drift piled against the motor pool fence. 15-degree slope, soft sand. The Jeep climbs without hesitation. Bellini stops mid-slope, holds the brake, restarts from a standing stop. The Jeep doesn't bog, doesn't slip, just climbs. He tests the steering, remarkably tight turning radius, 6.5 meters curb to curb. The Jeep spins almost in place. He drives figure eights around fuel drums, navigates between stacked crates, reverses, smoothly, everything responds. Later, Bellini will write in his initial assessment, "This vehicle exhibits no single outstanding characteristic, yet the combination of adequate power, intelligent gearing, 4-wheel drive, lightweight, and simple construction produces capabilities exceeding theoretical specifications. The Americans have built not the best vehicle, but rather the most useful vehicle." The word useful will haunt him. December 12, 1942. Bellini supervises the Jeep's transfer to a workshop in Tunis proper. His team, 3 Fiat-trained mechanics, 2 electrical technicians, 1 metallurgist, and 1 young engineering lieutenant named Paolo Rossetti, fresh from Politecnico di Milano. Their orders? Complete disassembly and analysis. Document every component. Assess manufacturing techniques. Determine if Italian industry can produce equivalent vehicles. They begin with the body. The Jeep's shell consists of flat stamped steel panels. Minimal curves. Few. Compound bends. The hood, 2 simple flat pieces hinged at the center. Fenders, curved but not complex. The body sides, straight panels welded to the frame. Rossetti, the young lieutenant, runs his hands along the welds. "These are crude," he says. "Thick beads. Unrefined technique. We could do better." "Could we do this many?" Bellini asks. Rossetti pauses. Italy's automotive industry prides itself on craftsmanship. Alfa Romeo, Lancia, Maserati, beautiful cars built by skilled workers. But mass production? That's different. Fiat produces perhaps 80,000 vehicles annually, civilian and military combined. America produces millions. The metallurgist, Sergio Conti, examines the steel composition. Low-grade steel, he reports, high carbon content, brittle by Italian standards. This would never pass Fiat's quality control. Yet it works, Bellini observes. It doesn't crack, doesn't fail. Why? Conti considers. The thickness compensates. American steel may be lower quality, but they use more of it. Overbuild everything. Brute force approach. They weigh the body components, calculate steel usage. The Jeep employs approximately 30% more material than an equivalent Italian design would specify. More welding, more metal, more weight, wasteful by European standards. But waste implies excess production capacity. America has steel mills running constantly. Italy rations steel. American wastefulness is Italian luxury. They move to the frame. Welded box section construction. The main rails run straight from front to rear. Cross members provide rigidity. Simple, strong, overbuilt again. Bellini calculates the safety factor. The frame could support twice the Jeep's rated payload before yielding. Why design it this strong? Rossetti asks. Because they don't know how soldiers will use it, Bellini replies. So they make it strong enough for anything. Italian military vehicles are designed for specific purposes. Reconnaissance vehicles for reconnaissance. Supply trucks for supply. Command cars for command. Each optimized for its role. The Jeep seems optimized for everything and nothing. A generalist. Yet intelligence reports show Jeeps serving as ambulances, gun tractors, personnel carriers, supply vehicles, communication platforms, weapons mounts, even snow plows. The team removes the engine. The Willys Go Devil sits on the workshop floor, oil dripping onto newspapers. Conti begins disassembly. 4 cylinders, inline configuration, cast iron block, overhead valve design, displacement, 2,199 cubic centimeters, bore, 79.4 millimeters. Stroke, 111.1 millimeters. Compression ratio, 6.5 to 1. Rossetti records specifications. Low compression, he notes. Italian engines run 8 to 1 typically. Higher efficiency. Different fuel, Bellini says. American military petrol is lower octane, 80, maybe 87. They design engines for fuel, availability, not performance optimization. Smart. Italian forces in North Africa struggle with fuel quality constantly. German petrol, British petrol, captured Soviet petrol, all different octanes. Italian engines designed for high-grade fuel run poorly on battlefield mixtures. The Jeep's engine operates on anything flammable. Conti examines the cylinder head. Simple valve train, he reports. Side camshaft, push rods. No overhead cam complexity. Easy to service. He removes the oil pan. Look at this. The crankshaft shows wear but no damage. The bearings are scored but functional. Conti checks manufacturing tolerances. Loose, he mutters. American machining is imprecise. These clearances exceed Italian standards by 0.05 millimeters in some places. Yet the engine runs, Bellini observes. 60,000 kilometers according to the logbook, no major overhaul. Loose tolerances mean easier manufacturing, less precise machining required, lower rejection rates on assembly line, faster production, but also more oil consumption, more noise, less efficiency. The Americans trade perfection for production speed. They test the compression. All 4 cylinders read similar values. No significant degradation. The engine could run another 60,000 kilometers easily. Rossetti shakes his head. This shouldn't work. The engineering is adequate, not excellent, just adequate. Next, the transmission. Warner T84, 3 forward gears, 1 reverse, synchronized mesh on second and third gears, first gear and reverse non-synchronized. The mechanics drain the oil, dark but not burnt. They split the case. Inside, straight-cut gears show even wear patterns. No chipping, no excessive play. The synchronizers show normal wear for 60,000 kilometers. One mechanic, Franco Martelli, examines the shift forks. Heavy, he says. Overbuilt. Italian transmissions use lighter components. Italian transmissions also. Brake, another mechanic responds. Uncomfortable silence. It's true. Italian military vehicles suffer frequent transmission failures. Gears strip. Synchronizers fail. Clutches burn out. The problem isn't engineering knowledge. Italian engineers understand transmissions perfectly. The problem is materials and manufacturing quality under wartime conditions. They examine the transfer case. Spicer Model 18. Simple planetary gear set. High range. Direct drive. 1-to-1 ratio. Low range. Approximately 2-to-1 reduction. 4-wheel drive engages via dog clutch. No complexity. No hydraulics. A mechanical linkage from the dashboard lever activates the shift collar. Bellini operates the mechanism repeatedly. It functions smoothly every time. This is clever, he admits. Not sophisticated, but clever. A farmer could repair this with basic tools. Exactly. The Jeep's design philosophy prioritizes field serviceability over engineering elegance. Components are accessible. Simple hand, tools suffice for most repairs. The hood opens from either side. Engine access is excellent. The electrical system uses civilian standard components. A village mechanic familiar with automobiles can service a Jeep. Italian military vehicles, by contrast, require specialized training. Fiat publishes thick technical manuals. Qualified mechanics attend courses. Proper repair demands proper facilities. It's professional, precise. Completely impractical when your nearest service depot is 800 kilometers away across hostile desert. They move to the suspension. Semi-elliptical leaf springs front and rear. Ancient technology. Springs date to horse-drawn carriages. Modern vehicles use independent suspension. Coils. Wishbones. Complex geometry for superior ride quality. The Jeep employs none of this. Just simple leaves of spring steel stacked and clamped. Each corner mounts identically. Front spring, 9 leaves. Rear spring, 10 leaves. Shackles allow springs to flex as suspension. Cycles. Rossetti measures the spring rates. Harsh, he reports. This rides terribly by civilian standards. But it works across terrain that would destroy independent suspension, Bellini counters. They test the theory. Using jacks, they simulate articulation. Full droop on one wheel, full compression on the opposite corner, maximum twist on the frame. The leaf springs flex. The frame twists slightly. Nothing binds. Nothing breaks. The Jeep maintains wheel contact throughout the cycle. Independent suspension offers better on-road comfort. But crossing boulders, trenches, ditches, simple leaf springs prove nearly indestructible, and crucially, they're repairable. A broken leaf can be replaced individually. A broken coil spring requires complete assembly replacement. The Americans chose durability over comfort. December 22, 1942. 2 weeks into disassembly. Bellini's team has catalogued 417 individual components. They've weighed every part, measured every dimension, analyzed every material. Rossetti compiles data while Bellini reviews intelligence reports from the Russian front. Soviet accounts mention American Studebaker trucks. British reports praise American half-tracks. Everyone discusses American production numbers. Preparing and narrating this type of story took us long efforts and hard work. So if you are enjoying the story, please consider subscribing to our channel. The numbers don't make sense. Bellini reads them again. American automotive production, 1942. Approximately 3 million military vehicles. Trucks, jeeps, half-tracks, amphibians, 3 million. In 1 year, Italy's entire automotive industry produces perhaps 90,000 vehicles annually. Germany, with its vaunted industrial might, manages perhaps 300,000 military vehicles yearly. America produces 10 times Germany's output. How? Bellini spent 2 years at Fiat's main plant in Turin. He knows automotive, manufacturing, body stamping, frame welding, engine assembly, paint, trim, testing. Each vehicle requires dozens of man-hours, skilled workers, precision equipment, quality control. You cannot simply wish production into existence, yet America does exactly that. He studies the Jeep's components again, sees the pattern. Every tolerance is slightly loose, every design choice favors simplicity over optimization. The Americans aren't building the best vehicle, they're building the vehicle they can manufacture fastest. Rossetti enters with calculations. Major, I've analyzed the manufacturing requirements. The Jeep requires approximately 160 man-hours to assemble. Comparable Italian vehicles require 280 to 320 man-hours. Why the difference? Simpler construction, fewer custom parts, more automated stamping, less hand-fitting. Rossetti pauses. And lower quality standards. There's that word again, quality. Italian engineers pursue perfection, every component optimized, every tolerance minimized, every surface finished properly. It's engineering excellence, but perfection takes time, and time lost on the assembly line is time the enemy spends building more vehicles. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. January 8th, 1943. Bellini's team begins reassembly testing. They want to verify the Jeep's claimed capabilities. The motor pool provides a test course. Sand dunes, rocky slopes, mud pits, stream crossings. Load testing comes first. They pile sandbags in the rear, 100 kilograms, 200, 300. 363, the official payload limit. The Jeep squats slightly. Suspension compressed, but within normal range, Bellini drives the loaded vehicle across level ground. Performance remains adequate. He attempts a moderate slope, perhaps 20 degrees. The Jeep climbs without struggle. They add more weight. 400 kilograms, 450, 500. Now the Jeep's springs compress fully. The rear bumper nearly touches the ground. Bellini expects failure. Broken springs, cracked frame, something. He drives the test course anyway. The overloaded Jeep climbs the 20-degree slope, slower than before, engine laboring, but successfully. It crosses the mud pit, rear wheels churning, threatens to bog once, regains traction. Continues. The rocky section proves hardest. Suspension bottoms repeatedly. Metal crashes against metal. Bellini winces at every impact, but nothing breaks. They complete the course, unload the sandbags, inspect the vehicle. Franco Martelli examines the frame. No cracks, no permanent deformation. These Americans over-engineered everything. Or no soldiers overload everything, Bellini replies. They continue testing. Maximum grade climbing. Bellini finds a steep escarpment, approximately 35 degrees. Impossible for most vehicles. He engages low range, four-wheel drive, locks the differentials, approaches slowly. The Jeep begins climbing. Front wheels scrabble for traction. Rear wheels push. The vehicle tilts backward alarmingly. Bellini fights the urge to brake, maintains steady throttle. The Jeep crests the slope. Rossetti, watching from above, shakes his head in disbelief. 35 degrees, that's impossible. Apparently not, Bellini says. They test side slopes. 20 degrees lateral. The Jeep tilts. Inside wheels lift slightly, but the narrow track and low center of gravity provide stability. 30 degrees. Now it feels dangerous. The vehicle wants to roll. Bellini stops the test. No soldier would attempt this angle deliberately. Water crossing. A shallow wadi, 60 centimeters deep. Moving current. Rocky bottom. Bellini drives in slowly. Water engulfs the floor. Sloshes over the transmission tunnel. The engine continues. Running. The electrical system, mounted high, stays dry. The Jeep fords the stream without hesitation. Deep water test. They find a flooded area, 90 centimeters deep, above the floor level. Bellini hesitates. This exceeds specifications, but intelligence reports mention Jeeps fording rivers. He proceeds. Water surges through the cab, soaks everything. The engine sputters. Bellini gives more throttle. The Jeep pushes through, emerges dripping on the far bank. The engine still runs. Conti laughs. This machine is waterproof. Water-resistant, Bellini corrects, but the point stands. The Jeep's engine breathes through a high-mounted air cleaner. The electrical system routes above potential water levels. The distributor is sealed. The starter is protected. Americans designed this vehicle expecting soldiers to drive it through anything. Speed testing. They find a flat stretch of desert. Bellini accelerates in high range, fourth gear equivalent through the transfer case. The speedometer climbs. 80 kilometers per hour, 90, 100. The Jeep vibrates, the steering loosens. Wind tears at the canvas top. 105 kilometers per hour, maximum speed achieved. Not fast by automobile standards, but remarkable for a vehicle weighing barely over a ton with 60 horsepower. They test fuel consumption. City driving, approximately 14 litres per 100 kilometres. Highway driving, approximately 11 litres. Cross-country, approximately 20 litres. The 57-litre tank provides 250 to 300 kilometres range depending on conditions, less than Italian vehicles. But Jeeps can refuel anywhere. Their low fuel consumption in absolute terms means even small supply dumps can service multiple vehicles. Maintenance testing. They change the oil. Simple. One drain plug, one filter, ordinary tools. Total time, 15 minutes. They adjust the brakes. Accessible. Well-marked adjusters. 20 minutes. They replace a spark plug. Remove the hood. Access is excellent. 5 minutes including finding the wrench. Bellini asks Martelli to simulate a battlefield breakdown. You're under fire. The engine won't start. You have 10 minutes and a basic toolkit. What can you check? Martelli opens the hood. Checks distributor cap. Inspects plug wires. Examines fuel pump. Tests battery connections. Everything is accessible. Everything is obvious. A competent soldier could diagnose most problems in minutes. They compare this to an Italian vehicle. The Fiat 508 centimeters, engine buried under the hood, cramped engine bay, specialized tools required for many operations, beautiful engineering, terrible field serviceability. One of Bellini's mechanics served in the Western Desert before reassignment. Major, he says quietly, our vehicles break down constantly. And when they break, we cannot fix them. We abandon them. The British capture them. And American vehicles? Bellini asks. They break too. But the Americans fix them. I watched British recovery teams patch Jeeps with wire and spare parts, engines that should be dead running on 3 cylinders, vehicles held together with field repairs, but still running. This is the revelation. The Jeep isn't superior because it never breaks. It's superior because when it breaks, anyone can fix it. Italian engineering produces machines requiring skilled technicians. American engineering produces machines requiring only soldiers with wrenches. January 25th, 1943. Bellini compiles his preliminary report. The document runs 73 pages. Technical specifications. performance data, manufacturing analysis, tactical implications. His conclusion occupies one paragraph. The American Willys MB Jeep represents not superior engineering but superior design philosophy. Every component prioritizes field utility over laboratory perfection. The result is a vehicle of moderate capabilities that functions reliably under all conditions, can be repaired by minimally trained personnel using basic tools, and can be mass-produced at scales Italian industry cannot approach. The strategic advantage provided by 64,000 such vehicles exceeds that of 6,000 superior vehicles. We are not losing to better engineering. We are losing to more practical engineering implemented at industrial scale. He submits the report to headquarters in Rome. Waits for response. Meanwhile, the war grinds forward. The Battle of Kasserine Pass begins February 19th. American forces, inexperienced, take heavy casualties. German tanks maul American positions, but American jeeps evacuate wounded, transport ammunition, maintain communications, provide reconnaissance. The battle is an American tactical defeat, but American logistics prove resilient. More jeeps arrive, more trucks, more equipment. The Americans lose battles but never lose their supply chain. German and Italian forces, by contrast, fight desperately for every litre of fuel, every spare part. Italian trucks break down regularly. Fiat 508 seconds bog in sand. Lancia 3 ROs crack cylinder heads in desert heat. Abandoned vehicles line retreat routes. March 19th, 43. Bellini receives orders. Report to Rome immediately. Bring complete Jeep analysis. Present findings to the Ministry of War. He travels north, away from Africa's collapsing front. The Mediterranean crossing proves hazardous. Allied aircraft dominate the skies. The transport ship dodges attacks, reaches Italy. Rome feels distant from the war. Citizens queue for rations, but bombs haven't fallen yet. Bellini reports to the ministry. Ancient stone building, marble floors, Baroque paintings. Feels like museum. He's escorted to a conference room. 15 officers await. Generals, colonels, technical specialists, and one civilian. Vittorio Valletta, managing director of Fiat. Colonel Mancini opens the meeting. Major Bellini, your Jeep report. You claim this American vehicle is. What was your phrase? Explain. Bellini stands, distributes copied specifications. The Jeep succeeds not through advanced technology, but through intelligent compromise. Every design decision favors reliability, serviceability, and mass production over theoretical performance. Compromise. General Montini snorts. We don't build compromised vehicles, we build proper military equipment. With respect, General, we build excellent military equipment, in inadequate quantities. Silence. Dangerous silence. Criticizing Italian industry to its leaders is unwise, but Bellini continues. The Americans produced approximately 64,000 Jeeps in 1942. We produced perhaps 8,000 light vehicles total. They outfit every unit with reliable transport. We ration vehicles to priority formations. The advantage is overwhelming. Valletta speaks. Major, I'm familiar with American automotive production. Fiat cannot match their scale. We lack their industrial base, their assembly lines, their supplier networks, their steel production, their rubber supplies, everything. I know, sir. That we admit defeat? I propose we learn from their approach. The Jeep isn't perfect. It's practical. We could design a simplified vehicle, reduce complexity, loosen tolerances, prioritize production speed over quality. Multiple officers speak at once. Objections, protests. Italian engineers don't produce inferior goods. Standards exist for reasons. Quality matters. Bellini waits for quiet. Gentlemen, I'm not suggesting we build bad vehicles. I'm suggesting we build good enough vehicles in sufficient quantities. 1,000 adequate vehicles accomplish more than 100 excellent vehicles. This is defeatist talk, Montini says. We cannot abandon our standards. Then we abandon our armies, Bellini replies. Too far. He knows it immediately, but he cannot unsay the words. The room erupts. Colonel Mancini calls for order. Takes 5 minutes to restore calm. Valletta raises his hand. Major Bellini, your technical analysis is thorough, but implementing your suggestions requires resources we don't possess. Retooling factories, redesigning production lines, training workers, all while maintaining current output. We cannot do this. Why not? Because the Americans bombed our factories. Our supply chains are disrupted. Our workforce is depleted. Our material allocations are fixed. We operate under constraints you don't see from Tunisia. Bellini understands. He's criticized symptoms while ignoring the disease. Italy's automotive industry isn't choosing perfection over practicality. It's struggling to produce anything at all under wartime conditions. The Jeep succeeds because America possesses unlimited resources: steel, aluminum, rubber, oil, skilled workers, intact factories, secure supply routes. Italy has none of these advantages. The meeting concludes unsatisfactorily. Bellini's report is acknowledged, filed, forgotten. He returns to North Africa in April. The situation deteriorates rapidly. German and Italian forces retreat into Tunisia, surrounded. Supplies dwindle. On May 13, 1943, Axis forces in North Africa surrender. 275,000 soldiers become prisoners, including Major Carlo Bellini. He spends 3 years in Allied prisoner-of-war camps. First, Egypt, then Britain. Eventually transferred to the United States in December 1944, he's interned at a camp in Colorado, housing Italian officers captured in North Africa. The camp is austere but adequate. Food is sufficient. Medical care is provided. Boredom is the main enemy. But Bellini requests permission to work. American regulations allow prisoners to volunteer for agricultural labor. He's assigned to a local farm, drives a tractor, maintains equipment, and everywhere he looks, he sees jeeps. Farm jeeps, postal jeeps, civilian jeeps. The vehicles are ubiquitous. When the war ends in May 1945, Bellini remains imprisoned until repatriation begins. He returns to Italy in February 1946. The country is devastated. Cities bombed, infrastructure destroyed, industry shattered. Fiat's Turin plant is partially rebuilt. They rehire engineers. Valletta offers Bellini his old position. He accepts, spends the next 20 years designing trucks for Fiat. But he never forgets the Jeep. In 1950, Fiat begins producing the Campagnola, a light military vehicle influenced by Jeep design principles. Simpler than pre-war Italian vehicles, more practical. It serves the Italian army for decades. Rossetti, the young lieutenant from the Tunisia team, also returns, joins Alfa Romeo, designs racing cars. Occasionally, he and Bellini meet for coffee in Milan. They reminisce about the captured Jeep. We thought we were analysing a vehicle, Rossetti says during one meeting in 1962. We were actually witnessing industrial philosophy. America didn't win through better tanks or planes, Bellini replies. They won through logistics, through having enough vehicles to supply every soldier. The Jeep was just the visible symbol. Do you think Italy could have built something similar? No. Not during the war. We lacked everything necessary. But we learned. The Campagnola, the Giulietta, modern Fiats. They all incorporate lessons from that analysis. Practical engineering, serviceable design. We stopped pursuing perfection and started pursuing functionality. They sip espresso, watch traffic pass. Modern Fiats, some carrying loads they shouldn't, running longer than they should, braking less than they used to. In 1968, the Willys Jeep celebrates its 27th production year. Civilian versions flood global markets. The design, essentially unchanged since 1941, still sells, still works, still runs. American military finally replaces the Jeep in 1983 with the WWII, 42 years of service. No other military vehicle matches this longevity. The secret? That design philosophy Bellini identified in 1943. Good enough. Simple enough. Tough enough. Practical enough. Today, approximately 200,000 original Jeeps survive worldwide. Museums, collectors, restoration projects, some still run, still climb hills, still ford streams, 80-year-old vehicles performing tasks they were designed for. This is engineering legacy. Major Carlo Bellini dies in 1979. His obituary mentions his work at Fiat, his contributions to Italian automotive design. It doesn't mention the Jeep analysis. That report remains filed in Italian military archives, mostly forgotten. But the lessons persist. Modern military vehicles prioritize reliability over sophistication, field serviceability over engineering elegance, mass production over artisanal quality. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.